All right. Good evening, everybody. Appandarajan, Poornachandran here. A quick introduction about myself, and then maybe we will go ahead with this webinar. Thanks for joining. So, Appandarajan, Poornachandran here. You can call me Rajan. I work as a senior Scrum Master in a service-based company for around 18 years of experience. I'm here today to talk about lean management. In terms of ground rules for this session, let's if you guys want to stop anywhere, please don't hesitate. Let's have a discussion, lively discussion. Stop me anywhere you want, and let's please do share your experiences. Let's learn from this session. So that's the agenda. So I hope you're able to see me and hear me properly, and also my deck is visible. Can you take it as a yes? All right. Thanks, Tejas. All right. So, all right. So, minimize this. All right. So, I'm here to talk about lean management today. So, quickly going into the agenda of the session is we are just going to give a snapshot of what is lean management. We are trying to look at a case study.
Rajan, sorry to disturb. We can only see the folder. We cannot see the PPT. I believe we have to share this.
Let me share again. Trying to share again.
Yeah.
How about now?
Yep. Thank you.
Yeah, great. Thanks, Rob. Okay. The agenda of the session is we'll have a quick introduction about lean management. We will try to look at a case study between how Ford and Toyota works. We will talk about value streams, different types of waste, how actually any kind of product or software is being developed through lean. We will talk about the roles and responsibilities of a system designer. We will talk about set-based innovations, trade-off curve sheet, and we'll try to wrap up. So quickly moving into what is lean. So basically, if you look at Toyota, okay, they always have a record sales year on year. They are the irrespective of any kind of economy that what Japan is facing, irrespective of whether they have a 0% growth or a recession, always they have a record sales, irrespective of how their competitors perform on the market. So there are some intrinsic attributes because of which they are able to perform well in terms of they're able to produce cheapest cars, which their competitors are not able to produce. Their rollouts or callouts are really very less. The quality is good. So what is the attribute that is making them work this much efficient? One is any project that is taken into the Toyota manufacturing, they look at what is the value that it is trying to produce. Is it giving me revenue? They're trying to visualize the value. Okay, when I start a project, this is what I am trying to perform or I want to achieve. This is my objectives. Now, how do I execute that project? So they're able to visualize that flow chart sketch of how do I execute that project. Now, when they try to visualize that, how do I execute that project? They're trying to identify what are the waste. How I will, it's okay to make mistakes. How do I learn quickly? How do I make continuous improvements? So these are the basic fundamental blocks through which they implement lean. So this is what we are going to cover in this session. So quickly going into this case study of Ford and Toyota. Okay. Henry Ford and Kiara Toyota, both are highly skilled professionals. They have a vision to produce, say, a world-class car. They're technically qualified, but each one had their own strengths. Each one had their own limitations, and they faced a different challenge altogether. Now, if you look into Ford's perspective, Henry Ford actually built his own car on his own hands. He knew what he's trying to make. But his real challenge was, how do I make this car efficient on a large scale basis? That was his challenge. he knew technically of what needs to be done. So he was able to say, okay, do this step A, do this step B. So he was able to tell his team what needs to be done. And one philosophy that what Ford was trying to implement was the management should be in control of what is happening. They were giving more emphasis on process. Their idea was, let's make it a process-driven approach, then rest all will come in place. Their concept is more of a command and control, focus more on process. The other strength when Ford started their plant at Detroit was already it was a flourishing industrial town. So they were able to get the infrastructure set up. They were able to get up good engineers. There were good colleges. They were able to get good technicians. So he had that infrastructure set up, and his approach was emphasis on the process, rest everything will be on place. So you can even make a donkey work. It's not people representation. It's all about process. That's all about. Can everybody go on mute if you're not talking, please? So that was the approach of Henry Ford. Now, if you take parallelly Kyoto Toyota literally did not know how to make a car. He went to the US, saw the setup, and he came to a conclusion that he will not be able to make a car. Okay. So then he went back to his Japan, to his place, and told his father, look, it's nearly impossible to make a car. He said, nothing doing, let's follow our dream. He started the plant in a rural village setup, absolutely no colleges, no good technicians, no engineers, no infrastructure setup. Problem with Kyoto was he did not know how to make a car, so he was not able to tell people what needs to be done, which is exactly the opposite of Henry Ford. So he made an approach like, okay, let's make mistakes. Let's throw the bureaucracy off. Let's work as a team. Let's focus on what value I am going to generate. That's how they tried to build a car. They literally did not have any technical expertise. Believe me or not, when they were trying to mold the car, okay, they just literally dug a pit, put a car upside down, put it up. That was the technical expertise that they had. But only thing that they had was they were clear with the objective of what they are trying to make. I have to make a world-class cheapest car. We will work as a team. It's okay to make mistakes, but we will learn quickly from it. You make sure that the learning cycles are much faster and proceed. Give more control to the team which is trying to develop the car. That was the move. That was the different kind of challenges or similarities of how each one countered in terms of Ford and Toyota. Quickly moving on to, okay, I have an objective. Toyota had an objective saying that I need to make a fuel efficient car. Okay, I had an objective. That's the project. Okay, now how do I realize that? I need to make a car. Okay, fine. I have a concept. Now I'll have to generate that as a value. So anything that is a sequence of steps. Okay, so I need to make a car. So I need to do this particular step 1, step 2, step 3. I go to these end steps, and then I make a car. So you have the sequence of sketch of flow chart, right? That is what we call as the visualization of the value that we try to deliver. So that is nothing but your value streams. So value streams are nothing but your flow chart of how the sequence of steps that I do, either to deliver a product or deliver a service. It can be anything. Your order shipment, you book a ticket, book a ticket at your app, you do an Amazon buy. So all these are kind of services that you do. So you're trying to visualization of what I need to do for that. That is value streams. Now let's take a simple example. Okay, we go out for lunch. We all go out for lunch, right? So I'm just trying to simplify here, and we're trying to understand what is. Now we should have understand what is value streams. Value streams are kind of sequence of steps where I deliver a product or a service. Now, we are trying to categorize these value streams as either an operational value stream or a development value stream. Now, let's say we all go for lunch or dinner out. So what do? I first book a table, and then I go to the hotel. Waiter receives me. They give me a table, and then I order food. Then the waiter waits for the food to be delivered, and then he gives it back to us. And then once the food is done, then we get some kind of a feedback. And then once the feedback is kept, they do the billing and the value that is an happy customer. So this is what we were talking about, the sequence of steps. The first row that what we were talking about is nothing but your operational value stream. Okay. Now, if I have to book a table, what do I need to do? I need to either call the hotel or I need to use an app. Okay, I order a food. What do I need to do? I need to have some kind of a system where he uses an iPad and there is some kind of an app. So whenever we try to pick and choose, it's just to order. So automatically it goes to the central kitchen. And then once the food is ready, there's some kind of an alarming system notification. Then he brings back all the food. Then for the feedback system, there is some kind of an application and you have a billing software. So the first row that what we saw was nothing but the operational value stream. To realize this operational value stream, I should have some kind of applications or systems. Okay, the second row that what we were talking about, this row is nothing but your development value streams. So this is the difference between your operational value streams and development value streams. So development value streams objective is to create your operational value stream. So this is what we were talking about. As development teams, we try to make sure that we produce value by creating this development value stream. In turn, it creates an operational value stream to give a value. I take a pause here. Are we clear in terms of differentiating between an operational value stream and a development value stream? Go ahead. So you don't have to raise your hand. You can stop me anytime, Tejasvi. Please go ahead. Go ahead.
Okay. Hi, Rajan. Just a question like operational and development value stream, as it is mentioned. So book a table, there is confusion for me that a book a table, order food, that process is operational, like that we are visualizing it, and development is like we have developed it, like you're using the app, we are booking the table and then delivering the food. So that would come in the development stream, right?
Correct. So the first row that which is in tabular columns, there is a divider here. I'm not sure whether it is clearly visible. So the first row that what we are talking about, say from an hotelier perspective, this is I need to have a hotel and I need to have a happy customer. A happy customer is my value. For that, what do I do? From a customer perspective, he needs to book a table, he needs to order, he gives the feedback, then he gets the revenue. So the first row is nothing but your sequence of steps through which you deliver a service, which is nothing but your operational value stream. Now, to realize this operational value stream, I need to have systems and subsystems. So the second row is nothing but your development value streams.
Okay, got it. Actually, I was confused in that. So I cleared it. Thank you.
Right. So you don't have to raise your hand, stop me anytime. So let's have a lively, good session. Please do share your experiences. That's the whole agenda. So you don't have to wait for me to pass. So quickly moving to recap what we discussed. So value streams are sequence of steps where I deliver a product or a service. It can be anything of that sort. One thing that whenever we talk about value, right? So in Lean's perspective, value is not just what revenue that I get generated. It's not about just the dollars or the money part. We were talking about Toyota, right? They were just not focusing on, I need to make this much as revenue. That was one part of their goal. But the second part was, as a team, what did I learn? I did a project A. As a team, what did I learn? What mistakes did we do? So if there are any external members, how are they going to understand from the learnings that what we have? So value means the money generated plus what you've learned. So that is the key part of understanding what is value. So because we are trying to put it, sketch it as a sequence of steps, we are trying to look at what do you say as lead time and cycle time. So the benefit of making is value streams is, one is I generate money. The second part is, as a team, what knowledge did I gain so that I can reuse or somebody else can reuse at a later point of time for the future. That is considered as value. Now I have a concept. From the concept, I realize that as an order shipment software. So there are a sequence of steps, right? So I may be having n number of concepts. We won't be able to implement all the concepts. So from an opportunity, you go to your higher authorities and say, these are all the opportunities that I have. They will try to pick either one of them. Then you try to do some kind of a prototype. Then you try to fix the design. Then you actually start working on the software and you implement the software and deliver the software. So it's a sequence of steps, right? So right, all from the sequence of steps, right from the idea to actual shipment is nothing but your lead time, the sum of all these times. It's just a concept in the mind. Then I do some kind of a prototype. Okay, I am trying to fix that prototype. Then I come out with design and architectures. Then you give the design and architecture to the development team, and the development team tries to make the software and ship the software. So there's a cycle here, right from the concept till I deliver that software is what we call as a lead time. Cycle time is nothing but you already have a design. It is just your development time. I pick that, start developing it, then trying to deliver that. That's cycle time is purely a development time. Lead time is purely right from the concept till I deliver the software. So why do I do value streams? Value streams is you try to eliminate waste when you try to look at these kind of metrics like lead time and cycle time. So just make sure that you understand what is the difference between a lead time and a cycle time. We have these kind of metrics to make sure that you eliminate tasks. One of the important factor that what we were trying to look at of why I need to use lean. Why do I need to visualize value is more about coming out with these value streams so that I try to find where is the wastage that happens. That's why we do this. So this is all about value streams. Go ahead, Tony.
Hello, sir. Actually, can you please go back to the last slide where lead time and cycle time is there? You said that cycle time is the time which is used for the development of any process by the team. And lead time is the total time from start to the finish to the end result. So we can say that cycle time is a part of a lead time.
Perfect. So lead time is the superset. Cycle time is the part of it. Let's take a simple Kanban board, okay? Simplest thing, where you have something like, you have a board where you have something like discovery, you have analysis, then you start designing, then you start it's ready for development, then it goes through this process. So from ready for development till actual done is nothing but your cycle time. Lead time is right from the discovery column till the done is the lead time. Lead time is a superset like what you said. Cycle time is just a part of the lead time. You're right.
Okay, thank you.
So just to sum up again, we are using this streamlining, visualizing of the sequence of steps simply to understand where is the wastage that is happening. Whenever lean talks about value, value is not just the money that is generated. As a team, what have I learned? That's more important. So that's all about, and we should have understood something about lead time and cycle time. So quickly moving on to kind of wastage that happens in lean. Okay, so I have created a value stream. So the team develops a product. Now I have delivered the project. Now, how do I know whether this project has delivered real value or not? How do I know that? Anybody wants to pitch in here? I've developed a project. Now, what is the metric that I'll have to look out for if to say whether the project is a success or a failure, whether it is really delivering some value to the customer?
If there is a customer acceptance, like he gives a feedback that it has met his requirements, then we can consider that it has been successfully delivered.
That is kind of a process-based approach. Okay, so that is one thing. But from a developer's perspective, from the development project, have I earned money or not? The return of investment. I have spent for a month around $100. What did I earn after a month? So I've spent this much. This is what I got after selling the software. The return of investment is one metric. Now, if you look at acceptance criteria matching or not, that is more of a whether the story is completed or not. That's more of a process driven. That is not value. Right? So whether it is accepted or not is not value. But what is the customer getting out of it in terms of generation? Is he able to make the customer happy from what we were talking about, the example here? Is that a happy customer? Is he able to generate money out of it? Is the value. So if I make a software for this hotel here, I spend this much. This is my investment amount. This is my expenditure. This is my revenue. So I look at the return of investment. What is the profit that I get? So that is one metric. Okay. The other metric would be to ask the development team. Say, for example, can everybody go on mute if you're not talking, please? So the other metric would be to ask a developer, okay, per day you work around 8 or 9 hours a day. How many hours you actually develop the software? How much time do you spend useful? He would say around 5 to 6 hours. 1 hour or 2 hours is in meetings. He does some kind of an administrative work. So he would give a kind of a classification. So Lean tries to classify any kind of work item as these three parts. One is a valuable work, which is actually directly delivering a software or delivering a service or a product. The other is a waste. We consider waste as which is not giving any value. The other is a non-valuable one. So this is just categorization of work. Value-added work, Lean would say, okay, how do I improve this? Okay, today I say I work for 3 hours a day. How do I improve this value? Waste we can get rid of. You will identify waste and try to see how to get rid of. That's not a. The tricky part here is non-value work. When I say non-value work, it is not a waste, but it is a necessary activity. Say, for example, you have an office complex, okay? There are about 100 engineers there. They make software. But there will be some kind of a facilities department where they clean the floors, mop the floors. They are not directly providing value to the company. But you just cannot discard them, right? You need a clean environment. You need a. So if you talk to a facility manager, interact with him, he would be able to say, okay, how many seats are empty all the time? He will be able to give you all that information. So this non-value work is all about how to streamline it, how this non-value work items can support this development team, or how do I support this value-added item? We can get rid of waste, but we'll have to streamline this non-value work. Say your HR, marketing, procurement, quality department, they don't directly impact your value, but they are supporting agents to delivering some value, right? Even for that case, development is a kind of a non-value. As such, development doesn't make any sense to the customer. You develop it in a technology, you prepare an architectural document, you come out with test cases, hundreds of documents. I don't really care. What is the value that you have delivered through the software? Where is the shippable software? That's what the customer will look out for. So when we are looking at different types of waste, first we'll have to categorize the work. One work is kind of waste, we can get rid of. One kind of work item is value-added item where we can increase it. The other third item is the non-value work, which is not directly impacting the value, but it is indirectly impacting. So we'll have to streamline this. That's the thing. So these are the three different ways of how we look at a work item. So go ahead.
Excuse me, Rajan, I have a question. Basically, I'm from manufacturing and I'm from IT, both blended knowledge I have. So my question is, when you say non-value added work for development, when I look into manufacturing part, we do R&D, we do a protos, we do development for the next seasons, which have a PO, purchase order, which is twice or thrice of the real MRP of that particular or FOB value. So for when I'm looking into this non-value, maybe it is not directly correlated to me in terms of a physical product.
Purchasing, the purchasing department is activity where they procure for your prototype. They try to facilitate that. Is those people or those work items are non-value items. But your actual creation of your prototype for the next year is actually a value-added item.
Okay, so that means the development team who are really the department which makes some development, they falls into the value added, but the supporting departments, the cross-functional departments are non-value.
Exactly. Project management is also non-value.
Okay.
As such, project managers are not billable. They are just facilitating the team. The CEO is facilitating the team. That's all.
Right. Thank you.
All right. So one important factor that what we were talking about building block in lean was learnings, right? It's okay to make mistakes, but we'll have to quickly stand up, learn, and go. Now, say for example, we all would have faced this kind of situation. I get into a new project. It's a burning project. I really don't know to say anybody, these are the skills that I don't know, right? I don't know where I am incompetent. That's the first quadrant that what Lean tries to look at. So the first quadrant is, if I need to get help, I really don't know what I don't know. That's the first step. Then you use these kind of Lean methodologies. You have these value streams or something like that, and you try to find out where are the wastage, where are all the gaps. Now, you get a picture of what is the gap in the project. Then you use these Lean principles, consciously you identify the wastage that is happening. You consciously try to make changes to it, convert this wastage either to non-value or value items. That's the third quadrant. Fourth one, you have your own pathway. You unconsciously move away from the standard pathway and make yourself competent. So this is how the learning cycle would be that what Lean proposes. So this is something that I found interesting that what I wanted to talk about. The first thing that any kind of turmoil, we really don't know what we don't know. I just cannot get help anything. So it would take some time of breathing space to understand what are the gaps in this project? How do I rectify it? Then you consciously make an effort using any of these methodologies, not just Lean. Then you try to consciously have your own pathway. You can have your own methodologies. So that's the learning pattern. But the whole fundamental block here is learning is an important attribute, and we'll have to make quick learning cycles to make mistakes and then learn out from it and create a knowledge base. That's the basic. So looking at different types of waste, Lean tries to categorize this as three kind of waste. Now let's come to the center part of handoffs. Okay, we were talking about Ford, right? Typically, Ford was more of a process driven. So where they try to segregate these roles and responsibilities. One would be an expert. Say, for example, you would have come across architects or process experts where they try to make rules to the company. So architect would try to design. So these are all some kind of specialized experts. And there'll be a development team who's going to implement it. And there'll be some kind of a project management who is going to make sure that whatever process that what this expert has provided is properly followed. He will try to come out with a kind of an execution of that project, whether it is following that process. And there will be a customer who is trying to give a feedback. So when will this handoff happen? According to Lean, what they try to look at is when you are trying to segregate or separate these responsibilities, then it's a perfect recipe for failure. So if somebody is going to provide you the knowledge in terms of design for your project, and the development team is going to implement it. Say, if I am a developer, I only focus on whether I completed a task A. Okay, I completed task A, I'll go for task B. I am not responsible if the project is successful or if the project is failed. I don't really care if the project is failed, project is closed, I move on to another project. I'm only responsible to complete a task. That's how I am framed, built. If there is somebody going to give me the design, and the manager is responsible or the higher management is responsible. If you always talk to this executives management, they will always talk about numbers. This quarter, this is the revenue. Next quarter, we are planning for this revenue. He is responsible for this project. But the irony is, for him, that development is a black box. He doesn't know in and out of what is the development process that is happening. He meets the customer and he gives the some kind of a specification, gives it to the developer. So there is a clear handshake that is happening. Each one is trying to do something else. And this is a perfect recipe for a failure. Now, Lean says that if I have to create, the expert has to create a design, there is a waiting time for the development team. So that is some kind of a waste. Okay, we are talking about. So if an expert is going to produce a design, so there is some kind of a KT, some kind of a documentation that needs to be prepared. Any documentation is considered as waste if that is not directly impacting the value. So there is a clear segregation of roles and responsibilities here, where the guy who actually develops the software is not responsible for anything. And the guy who is responsible for the project doesn't know anything about the project. The development process is altogether a black box. He would just only ask in terms of what is the bottleneck? Can I bring in somebody if there is a problem? Let's make this project a success. That's how a conventional project works. So quickly going to the sheet. So when you try to segregate these roles and responsibilities, the wastage that happens, one wastage is the waiting time, because there is some kind of an expert who is going to tell you what needs to be done. And there is some kind of a KT or documentation that's going to happen, which is considered a waste. So how does Lean answer to this problem? This is typical way of how we talked about how Ford works. Give emphasis to the process. I don't care who works on it. It is not people-centric. If process is in place, I'll be able to generate the revenue. That's how Ford talks about. Now, Lean says here, okay, the development team is the team which is trying to develop the software. Give the responsibility to him. Let him design what needs to be done. Let him talk to the customer. So if that is the approach where it's a team collaboration, that's what we were talking about. The project manager is going to give a helping hand. The functional manager is going to give the helping hand. The CEO is going to give the helping hand. The development team will set how many resources it needs. Development team will set the budget for the project. Right from the technical perspective, the development team is in control. They execute the project. Now what happens is that responsibility is given to the development team. He interacts directly with the customer. So this is the approach that what Lean proposes if we don't have a separation of responsibility. So the bottleneck here is there will be a waiting time, unnecessary documentation or unnecessary information needs to be passed, which is not of real value. So this is how Lean proposes to eliminate one kind of waste. The other is kind of scatter, okay? Any burning project, say if I am the project manager, the project is not going well, it's a burning project, it's not stuck to the deadlines. So what do I do as a manager? Okay, first thing that I say is, okay, I have a stand-up in the morning, end of day, we will have a stand-up, frequent meetings, right? Which is considered as a waste. I need to monitor them, micromanage them. Okay, this team is not able to deliver. Should you need extra resources? I have another guy expert in another project, pull him in here. If there is one guy that is needed, pull in 3 or 4 resources into this project to make sure this project is. So this is all about reorganization. Pulling more people in is actually going to hamper the project, because the more number of people, the more number of communication channels, more reporting that happens is actually considered as a waste. But all reorganizations are considered waste. When I say reorganizations, is bring in another expert from another project, add more people to it. All these are reorganizations. Simply bringing in people into it is not going to solve the problem. It's only going to make the problem worse. You're going to add more communications channel to it. There might be a case, it needs to be looked at case by case. There might be a case where we need to have a reorganization, but all reorganizations are considered as waste. So the better approach would be, give a helping hand to the team, look into the root cause. If there is a resource shortage, let's work on it. If there is a technical gap, let's work on it. But mere having frequent meetings, mere having more reporting structures, having more processes in, having check gates are saying that go or no go meetings is not going to help. That's the fundamental idea in Lean. The third one that what they are talking about is visual thinking. Okay, in a conventional project, okay, say for example, I am trying to develop a front-end application. You come out with a concept. In a conventional way of looking at softwares, you pick a concept. You put this is the UI that needs to be done. This is the database that I need to pick. This is the middleware that I pick. So at very early stage of the project, what you do is you try to pick up an item. You may do a prototype and then you go ahead with it. But I don't look at multiple options. I don't look at analyzing, okay, I have chosen solution A. What happen if I choose solution B? When should I use a solution B? Or when solution B will be a failure? When should I choose a solution C? So these kind of, at an early stage, look at multiple opportunities simultaneously. So when you do this kind of an approach, what happens is that from a testing perspective, what happens is that when you take a concept, then the test coverage is very narrow. I test based on the concept that what is the specifications. That's the problem with this visual. So visual thinking is nothing but we are trying to pick a concept at a very early stage of the project when we don't have full data. I say that this is the UI that I book, I will do a prototype. This is the database that will book. For this problem, this is the solution that I am going to take. I come out with some kind of a prototype. But I don't look at multiple options. I don't weigh the pros and cons of each concept. That's the problem with this approach. I am trying to assume things at a very early stage when I don't have literally no data. I make a decision, okay? You have made a decision. Where is the data points for that? I don't have that. You make some kind of a prototype. Okay, say, I'm going to use this database. That's something new. Okay, let's create a prototype for it. It's working. Let's go ahead. So the problem here is the testing coverage will not be as good as enough. And say, for example, once you finish your project, okay, you learned that of accessing a new database, you learned a UI layer, or say, for example, you take from the manufacturing sector, you had a new engineering concept and you learned for it. Okay, I do the project. Okay, So where is the knowledge that what you acquired? Where does it go after the project gets closed? It's a question what Lean asks. We don't have answers for that. You might have it as a paper, but do I really use that? Okay. So the other approach is, say, for example, I have used some kind of a test data for this project. What is the real knowledge is if I'm able to use that test data in some other project which is relevant to it. That is how his knowledge is being reused. They try to come out with a one-page problem statement where saying that, say, for example, we are trying to make an UI. I considered 2 or 3 different kind of UI frameworks. This UI framework works well at this particular kind of condition. It doesn't work in this condition. So I come out with a simple one-page solution so that it is not just stops here coming out with a conclusion or hypothesis of this one-page solution of when to use what. But if we are trying to implement it in another project, that's the way how I reuse the knowledge. In Toyota, there are some cars that are made even without a prototype development. That happens because of this knowledge that is being used from one project to the other. Because it falls under the safe regions, they pretty much know this has worked for them in this previous project, so this is going to work out here too. So these are the different types of ways that we are talking about. So to quickly recap what we learned, one is the handoff, where I'm trying to segregate roles and responsibilities, which is considered a waste. The other is the visual thinking, where I'm trying to assume things, where I'm not looking at multiple options, picking up an option at a much early stage when you don't have any data, that is considered as a waste. The other is a scatter problem, where your problem is not as per plan. So typically, from a conventional point of view, you typically try to reorganize things, add in more people, bring in your expert, which is considered as a waste. I take a pause here. Are we clear with this? So these are all considered different types of waste. Are we clear? Do you have any of your experiences in your old projects? You can just step in.
I'm a little confused here. Maybe it is my understanding level. When I'm thinking about a UI, when we are showing multiple options or using a previous UI, that means if you're developing a website, you are already thinking that it has to be similar to the other website.
Okay, let's take a simple example. Okay, you are making a website. Okay, so you need some kind of a database for it. Okay.
Right.
There is one guy saying, okay, the number of users who's going to use this is less than 1 lakh. Okay, that's the target users. There's one guy saying, okay, let's go for an Oracle database. The other guy is saying, okay, look, it's just less than 1 lakh database. Why should I go for a licensed version? Somebody says, I'm going to use MySQL as database. Somebody else says it's a MongoDB. So you have different options. Now, how do I pick? I need to have some data. You have multiple options. So you try to do some kind of a prototype. Say, MongoDB will work for, say, just for a theoretical thing, it will work for 1,000 years, more 1,000 users. More than 1,000 users, it will not work. It's an hypothetical case. MySQL will work for, say, for example, 50,000, but Oracle will work for. So this knowledge that what you gain out of it. Okay, you're filtering multiple options, coming out. If I need to pick a database, how do I pick? The conventional way is, okay, I had a prototype, picked one option altogether at an early stage, executed it, it worked. Okay, it worked for 1 lakh users, but did you look at other options? Is the question. No. Okay, there's another guy saying I will use some other database like MySQL. Somebody saying you will use Mongo. So you simultaneously look at multiple opportunities here, multiple alternatives. You come out with a result, a data. Okay, MongoDB works in these conditions. MySQL works in these conditions. Oracle works in these conditions. Now I have three-dimensional way of looking at things where I can pick which database I want depending upon the number of target users, which can be used in other projects for other scenarios too. Am I clear?
Yeah. Thank you.
That's the whole thing. Any other?
This handoff separation of responsibilities, I'm not able to get it.
Okay. So when you take a project, okay, you assume that you are a developer. Okay. So you fall under a development team. Are you clear with that?
Yeah.
Okay. And there'll be a manager to whom you report.
Yeah.
Okay. And there'll be some kind of, say, for example, a QA expert who comes up with processes, or some kind of an architect, or somebody who is trying to help you in your technical day-to-day work. He gives you a bigger picture. So he is an expert. And there is a customer whom you really don't interact. You don't know what he wants, what he dislikes, absolutely. So from your perspective, the roles and responsibilities are separated. Do we agree up till this one? Your work is only to deliver a particular piece of work. So it's a big software like what we were talking about here. So your job is to only create a form like customer feedback. But you really don't know how this piece fits into the entire program. There is another system. There are hundreds of systems. You really don't know how it fits. Your work is just to have a form, create an UI. When somebody submits it, it needs to get stored in the database. Then you will get it. So you only look at a particular task. You don't look at what is the value that you are trying to generate the customer. Do you agree with that?
Okay.
So you only focus about what work you do. Expert is not you. So you're not responsible when your project fails or project succeeds. You agree with that? You completed the project. You completed this task. That's fine. You move into another project. So there'll be some kind of an architect who gives you a roadmap of what needs to be done. He works on multiple projects. Again, he is not responsible. But the higher management is responsible, who is going to talk to your customer. You actually don't talk to your customer. So you understand the problem here? Do you agree with there's a problem here? Because you have separated different roles. Okay. So now what Lean proposes here, once again, let me finish it, then maybe. So what Lean proposes here is that from a development team perspective, you talk to the customer directly. You decide what is the budget of your project. When you say you, it's the development team, it's you have a project leader and all that stuff. So you decide how much money I need to invest. You decide how many resources you need. You decide the plan of when to deliver that software. Now, the responsibility belongs to this team. If you do this kind of segregation, what happens? The architect will give you some kind of architectural document to you and you deliver that. So there is a waiting time for it. He takes time to look into it. Then there is unnecessary meetings that happens where he will like to make you understand. There is some kind of a KT that happens. So these are all kind of unnecessary wastage. Rather, this is how Ford worked. Now we talked about how Toyota. So in Toyota, every car that is considered as a project. That chief engineer is nothing who controls that project. So he gives a plan to the CEO. He gives a plan of how much needs to be spent, how many resources he needs, how long will it take to execute that project. He gives that plan to them. Then the CEO or the executive management goes through some kind of a process, vets it, gives all the control to him. So he will hire or fire. He will make a car, but there will be functional managers, there will be CEOs, there will be admin department. Everybody will give an helping hand and the whole control is with that chief engineer. That's the approach where they're talking about. Go ahead. Sorry, I stopped.
Okay. Actually, this was what my question was. I work in a manufacturing plant and we have a cross-functional team. where responsibilities are defined for each particular individual, and yet a lot of times we all have a confusion who falls under which, uh, I mean, who is responsible for that particular event, or for that even a piece of work.
Right. Again, we are looking at more of a process-driven
Yeah.
approach, like how Ford adopts. Rather, what Lean says is, give all the power. You will have multiple departments, but for a car project, say for example, you are delivering some product, there will be some team which is actually trying to develop it. Give the control to him. Let there be all functional, multiple disciplinary teams, which is going to give a helping them. Give the whole control to him so that somebody takes that responsibility. Whoever is actually working for that product, that what you're trying to work on, is given the responsibility. Rest all gives a helping hand. That's the concept that what Lean proposes.
Okay. Now I get it. Thank you.
But the example that what you are trying to say is more, again, like a Ford approach of process driven. It's more of a blame game. Say, my architect did not give it. Quality department did not give it. That department did not give me the necessary data. That is a waiting time. So typically the example is what you're trying to say is nothing but a blame game, which is considered as a base.
Yeah.
So these are all the different kind of ways that happens. Shall we move ahead? All right.
Yeah. Thank you.
Take it as an is. Okay. Now we are looking at Lean kind of development cycle. So this is no different like what we've learned about plan, do, check, that. It's almost the same. But the way how Lean looks at it is we look at value, right? When you look at value, what is considered as value is you understand more about the customer. You know who your customer is. What are his likings? What are his dislikes? Why am I making this particular product? Why am I making this particular feature for the customer? Who's my vendor? Who's my supplier? What technologies that I'm using? So you're trying to ponder out questions of related to your customer, related to how it is going to get integrated. So all this knowing things is what is the first part of Lean development. You look out for it. Then you make your try to find out your root causes. You use the 5 why problem. Okay, why does this customer wants this feature? So you try to ponder on reasons of why part. Then you come out with some kind of an hypothesis. Then we try to do some kind of a prototype development. So in this prototype development, we do like what we discussed before in terms of looking out for multiple alternatives, not just sticking to one opportunity, going at it at an early stage. You do prototypes where you try to question which approach is right and wrong, and which approach should be used, which solution should be used at which case. So it all depends upon case by case. So you come out with some kind of data, then you talk to the whole team that why am I choosing this particular solution? Then you try to develop that particular product or a service. So this is how Lean looks at in terms of life cycle. So first, anything that your understanding about the customer is considered value. Anything that you consider why he needs this feature. Looking at what is the vendor looking out for, what technology. So all this cyclic is a typical life cycle of Lean. So looking at the pillars of Lean, okay, the first thing is what we talk about is alignment maps. We talked about this look part, right? Knowing about the customer, knowing about the product. So it's typically the same thing. So creation of alignment maps. So this goes something like left to right. So I am going to produce value. So development team or your engineering team is going to develop that particular product or software. So I should know the needs of the customer. What is his limitations? Knowing about the customer is the first thing. knowing about the product, what are the features that what he likes, what are the limitations. From a development team or from an engineering standpoint team that what is trying to develop a product, what are my strengths, what are my weaknesses, what are my limitations. If I use a vendor, what is his strength, why have I picked this vendor, what is his limitations, and what are the competitors' weaknesses. So you're trying to understand why I am making this product. It's all about this. Why am I making? So you have my way of create a value that what we talked about is I need to make a world-class car. Okay, I need to make a fuel-efficient car. Okay, if you want to make a fuel-efficient car, what is the customer needs? What are the features that the product needs? Okay, what is the strength of my team which is going to manufacture that car? Who are my vendors? So I make a sub part of it. I make a, say for example, engine part. Now, how that engine is going to fit into the whole system? How is my supplier going to help me out in the whole picture? What is the competitor doing here? So you try to ponder questions here and come out with collect this data so that when you make these value streams, you make these corrections here. So this is the one fundamental part of this alignment maps. Are we clear with this one? Before we move on. So basically you're trying to collect data of why you're creating this project, knowing about your customer, knowing about your integration points, knowing about the product. You're trying to collect data on that. Shall we move ahead? All right, it has yes. So we are moving to, so we were talking about this one, right? This part. So where the development team or the product engineering team takes full control. Rest all in terms of CEO, in terms of functional managers, they give a helping hand. So this is typically that. Your organization makes sure that it is around your project. It makes sure the project is successful. We were talking about CEO is responsible for making. As a developer, I'm not responsible. I'm just trying to accomplish the task. That shouldn't be the case here. So in Toyota, chief engineer, for every car that is being manufactured, there will be a chief engineer. Let me give you an instance. Okay. There is one hybrid called hybrid electric car called Pyrus in Toyota, where he first came out with a plan, went to the executive management committee saying that the whole goal is to make a fuel efficient car. Okay, right? So in terms of value, how much fuel efficiency it is going to produce? He came back with the result, something like numbers like 50%. So the guys who are trying to vet this project told, okay, if I have to pay this much money and my fuel efficiency is going to be only 50%, nobody's going to buy this car. So they told him, go back, rework your plan, come back with it. So he tweaked that, made sure that he made some changes there and increased this fuel efficiency, brought back, and they agreed on this project and he was given the whole power to control them. That is what we were talking about here. So your development team, when they say development team, the chief engineer is controlling the project. The manager is, or the functional manager is going to give a supporting hand. CEO is going to support hand. So this chief engineer will say, I will make a prototype at this timeline. I will try to manufacture this car, say after 1 year. This is what is my investment. My break-even time is this much. So he chooses his budget. He chooses his resources. He is given all the control. That's all that we are trying to look at here. So the chief engineer, it's not just now the CEO who is responsible for making the money. It's the development team that is also responsible for making money. So the responsibility comes from the top to the down here, where he is responsible. He creates his own plan, goes back, gets it vetted, starts working it, everybody else gives them a helping hand. So the development team is also responsible for making money. So the functional leaders, team executes, so they create a value stream, and the chief engineer executes that value stream, that what we were talking about. So if we take this example, he creates this app called the development team will create an app for it, some other development for application for the food, some other for the feedback system. So he controls this complete value stream. He generates this complete development value stream in term where we are trying to develop an operational value stream. Are you guys with me till now? Yes or no? If you have any questions, maybe if you want me to.
Yes.
So first thing that what we were talking about was knowing about the customer, knowing about the product, knowing about the feature. Then we talked about the waste here. So how do I eliminate waste? Give the control to the team which is actually functioning. Rest all gives them the helping hand. He is responsible for making money. Rest all gives an helping. So you're trying to align your organization around projects. Next thing is, so what we are talking about is the alignment to the business. You have a value stream. So it's something like a flow, right? So what is value? One thing is value is money. The other thing is flow of knowledge, that what I can reuse it. So I have a concept. From a concept, it is converted to cash, a revenue. Along with that, it is just not money. It is also the knowledge that I acquire, so that can be reused either by you, your team, or somebody else for that matter. So this is the basic fundamental pillar stones of Lean. I'll take a pause here. Are we good till now? Right. So just to recap, Lean tries to focus on learning cycles, quick learning cycles. We were talking about enterprise system designers. They are nothing but your chief engineers who take care of your value streams. They make sure they lead the development value stream. They make it profitable. They are accountable for the profitability. They create that operational value stream. You just not look at one option, you look at multiple options. It's not the CEO or the manager who's going to take this much work and do this. So the team decides the cadence in terms of how I'm going to deliver. I'm going to deliver something in terms of milestones, or I'm going to deliver it in, say, this quarter, next quarter. I'm going to pull that much amount of work which I can accommodate. So that's the crux of it. You have your own delivery system. Every 2 weeks, every 4 weeks, I'm going to deliver something. So as a team, you guys decide. So you guys decide how much work I can take. It's not somebody from outside who's going to tell you how much work you should take. You should complete it this time. So as a development team, they decide what needs to be picked because they know the voice of the customer. They know how to estimate things. How long will it take? It is not the functional manager or the manager who's going to decide how much will it take. So that's how it is. So, and the development team is given full control. I take a pause here. Any questions still? I think it is 1 hour. I think I'll take a pause here. Any questions? Let's have some discussion. Maybe we can have a follow-up meeting. I still have another half an hour to go. I don't want you to. Let's take a pause. If you guys want to continue, we can continue, or else we'll take a pause, have some discussion, and have another follow-up meeting, whichever works for you guys.
Hey, I have one question, sir.
Go ahead.
So, as you said before, that development team has full control. Can you tell me what's the differentiate between, it would be between development team and analytic team?
What do you mean by analytics team?
Actually, I joined a little late, so I wasn't able to come to your session
when
fully.
you say that's fine. When you were saying, you were talking about some analytics team, right? What
Yeah,
is that?
yeah.
What is that?
So if we are working into some analytics of data and everything, so that's what I want to do.
When you say development team, it is not just so analytical teams will be part of your development team, right? Anybody
So they would work hand to hand.
Yes. So
Okay.
anybody who's making a software, so your analytics data, somebody is going to work on this analytics. You use this data so that somebody uses this data. So you are part of the development team.
Okay.
I'm talking from a software perspective. Let's take a manufacturer. So there is an engineering department who is actually going to do the work. But there will be a purchase procurement department. There will be an admin department. There will be a functional manager. So the actual guy who's doing it, there will be a shop floor guy who's actually doing it. So they are the actual guys who are producing the product or producing a service. You're part of the development team when you say analytics.
Okay, sure. Thank you so much. That's all.
You want to continue? If you allow me to continue for another 10 minutes, I can wrap the whole thing and then we can have a discussion. Or you guys want to have a stop here, maybe have a follow-up meeting, whichever works. Now we are the development, so we have to decide how we go about. Shall we have a hard stop now and then have a follow-up meeting? Will that work? Or you want me to continue for another 10-15 minutes where we can wrap it up? Guys?
So you can continue.
Okay, let me quickly move on. So we were talking about chief engineers, right? That's nothing but your enterprise designers. So from a manufacturing perspective, for a car manufacturing, Toyota coins this word as chief engineers. If you take from a development software development perspective, I would say something like a project leader. That's just a role. Project leader manages the team, both from a technical perspective, also from the management perspective. So what is the role of this enterprise system designers or chief engineers who takes control? So like what we saw, it is not just in terms of revenue that I generate. It's also what did I learn from this kind of a development work. So anybody who's responsible for team learning. Toyota believes that to have a functional engineer, it takes around 10 years for them. Experiences where they consider that he is a kind of a functional engineer. So they take that as their responsibility to make sure their engineers are being taught, and that's their philosophy. So when we talk about the enterprise system designers or the chief engineers or the project leaders, if I am the project leader, my responsibility is not to generate revenue, just revenue alone, also to make sure the team learns. Make sure that I understand you have a particular subsystem. How is that going to get fitted to the whole system? I manufacture a car door. Okay. How is that going to get integrated to the car? How it is going to get fit? So I love to have a bird's eye view of a complete value stream, right? So I represent the customer. I am responsible for the money that is being generated or money that is paid. We were talking about different solutions, right? I have a solution A, solution B, solution C. I have a problem. Okay, which solution should I see? That is nothing but our trade-off. So we were talking about this, what do you say? Visual thinking, where visual thinking is nothing but you are trying to make assumptions even without you get full data. So you have a trade-off. So trade-off is nothing but you have multiple alternatives. You try out all that alternative. I tried out when to use Oracle database. I tried when to use MySQL database. I tried when to use MongoDB. came out with all the scenarios, came out with the data. Okay, at this particular point of time, I have to choose a particular solution A. Okay, this is a different scenario. I won't be able to choose solution A. Let me go to solution B. So that trade-off happens and that consensus happens. He leads that. So he has a cross-functional disciplinary where he makes sure that the project is run. That's his responsibility. All of it. So we were talking about the multiple options, right? Let's take the same Oracle database, and I don't pick a particular solution like what we were talking about. I don't pick a particular solution without any data, without making sure that I am pretty sure about it. So you try to look out for multiple of them. That's nothing but you learn from that, right? So solution B or solution C might not be used in this project, but that is the learning, that is the value that you get. I might have not used that solution B, but that's the learning that I get. Somewhere down the line, I'll be able to use that solution B. I know now when to use what. That is all about set-based concurrent engineering, where I look at multiple options. I try to run it through, filter that option, saying at this condition, this is not going to work. At this condition, this is going to work. I come out with a one-page solution. This one-page solution is going to give me a kind of an analytical data of when to choose what. Am I making sense here? That's all. Whatever that we talked about, they have just coined a word saying set-based concurrent engineering, which is nothing but looking at multiple options. So this is in terms of coming out with the learning. You're trying to innovate something, create a knowledge base for it. That is all about when you talk about set-based concurrent engineering. Am I clear here? Any questions here?
No.
All right. So in a typical conventional development, what happens? There is a brainstorm for the solution. Somebody says this is the solution. You pick one solution, that what we discussed about. If it is a new solution, you try to develop a user prototype, come out with that prototype, and then go ahead. But the problem is I cannot track back because I don't have, I have not even thought about another solution, plan A, plan B, plan C. I have not even thought about it. That's how conventional development works. But in the set-based convention, you have these value streams. So what the team tries to do is, team tries to sketch this flow chart. I have a value stream. I need to do this step A, step B. So for this step A, I need to have this particular system. So you try to break down into small understandable pieces of your system and a subsystem. Why do I make this subsystem? So what do I need to make this, say for example, let's take this simple example. What do I need to make an app? So I try to understand about the customer. Why do I need to make an application to ordering food? So you come out with different options. So right, that's what we were talking about. So So you try to come out with multiple options and alternatives. You try to identify why I need to make an app. I need to book a table for it. So you try to identify objectives for it. Come out with multiple alternatives. You try to understand which solution I need to pick based on the prototypes, multiple solutions that you develop. Now what happens is that, let's pick a simple example that what we were trying to do. I picked around 3 database tools. There might be a scenario where the number of users is just going to be 1 lakh. Let me use MySQL. There may be a system where I'm going to use, there'll be million users. So maybe just for argument's sake, maybe MySQL is not going to help. MongoDB maybe, that's another data. So you come out with some kind of a proof to pick which solution I need to do. You know the limit of performance, right? The test coverage that what we do. Okay, within this range, you are fine with this solution. If the threshold breaches, no, this is not the solution that we need to pick. we can pick another solution. So that knowledge that you gain, you look at failure cases, you identify the failure cases, you identify the success cases, you know what is the range, normal range, you know the threshold, you come out with all the data, so you create a knowledge base. Like what I said, I would have not picked this particular solution B on this project, but down the lane, this knowledge that what I gained might help some other team where they actually don't need to create a prototype. They can very well use this knowledge base, go and left shift, go and create a software. So you try to identify the range of your performance, the failure cases, the success cases. How do I reuse that knowledge? In that, what happens? You reduce the risk, you innovate, you learn, you avoid wishful thinking. Wishful thinking is like nothing but you only pick on one option, go ahead with it. At later stage, it may succeed or it may fail. It's just an assumption. So this is how the set-based innovation works. So once you do this, we were talking about a one-page problem, right? So it's a single page where you find out what is the problem statement, how do I rectify that problem, what is the root cause for it, what is the range in which it will work. So I'm just, that is nothing but what Toyota calls it as trade-off curve sheet. So any decision that they make, the first question that the manager will ask them is, where is this trade-off curve sheet? Show me that paper. That paper will give you all the data to tell which solution I have picked, why I have picked, at what range it will work. I'll be fuel efficient until this range if I use a particular engine. I can use another hybrid car of a different engine. For that, the fuel efficiency will be of this range. I'm just taking an example and oversimplifying. So that single page is nothing but one page design document or one page problem statement is what they call as trade-off curve sheet. Am I making sense here?
Yeah, this trade-off is for each new model they develop. Or
it can be for a system, it can be for a subsystem, it can be for a problem, it can be for anything. So you're say for example you are making an engine and there's some kind of a sub for it. There'll be multiple alternatives, right? So which one should I pick?
Okay. So for any component, it is mandatory.
Okay. It can be for a system, subsystem. You try to find out with the root cause. You try to find out with success scenarios, failure scenarios. You give ranges, just like our test report, blood test report. Right? This range, it works. You're good. You're healthy. If it is not within this range, there's a problem there. So that's all we are talking about.
Right. So if I consider one car, then there could have been like thousands of reports as such, right?
Correct. So wherever you are making a decision.
Right.
And when you are making a decision, Lean says that don't just stick to one solution, look at multiple options. Don't pick a solution without looking at other options. What is the alternative for it? Why am I not picking that alternative? That all is Lean talks about. So you spend some time here, but what happens is that the advantage is the next guy might use, you might have not used a particular solution, but that's how Toyota works. There are some cars where they say they literally did not even make one car as a prototype because they knew this is going to work because they have the data for it.
But in such case, are they increasing the development lead time? Because they are doing multiple permutations and combinations to get into one kind of a final solution.
I get it. So the difference here is that it is not that they will take for a particular problem statement, they will first try to run this solution A, and then they will try to run solution B. All this will be done concurrently at the same time. Quick learnings. That's all they're talking about. You can't say I try to create a prototype for a year, right? So you try to conquer it at the same time, multiple solutions. That's their fundamental.
Okay. because I'm typically looking at from my manufacturing experience where we make physical products. So if you have to have this kind of options in hand, actually it takes some time, but again, it is like finally you are trying to marry something which is not there. You visualize something and decide, okay, let's go with it and B. Yeah, got it.
So any decision that it works for Toyota, it works for Nissan. So it should work for any software industry for that matter, any engineering. So all that I try to say is that don't assume things, don't stick to a solution just because there is some bias to it or you feel that might work. Maybe you're trying to come at the later stage, you just cannot backtrack. That's there. So it doesn't happen that you pick this separately. They'll try to conquer it at the same time. That's how they learn. So this is how a sample kind of a trade-off curve sheet will look like. So I'm just trying to simplify things like what we were talking about. Say, for example, I came out with a problem saying that I was trying to use a database called MySQL, and my target users are more than 1 million requests per day. Right, so that's my kind of a business problem. So if I have to use MySQL, what do I do? So it's just a one page where you do some kind of an analysis or a prototype development. At the end of the day, the result that what you do out of this set-based concurrent engineering is you will have to come out with this kind of trade-off curve sheet, which will tell me at what is the normal range, when it will work, when it will not work. So all that this trade-off curve sheet is saying that my problem is I need a request that is being hit for more than 1 million. What do I do for it? So they came out with some kind of a configuration change where it will still work. If I make this configuration change in my server, I can make sure that 1 million requests are done. That's the trade-off that I do. But anything more than 1 million, this solution is not going to work. So they come out, we were talking about this normal range, right? So I've just pictorially put some kind of a graph just to make sure that this is the normal range. Anything greater than 1 million, this is not going to work. Anything less than 1 million, we are safe. We were talking about the safe regions, right? That's why we don't create a prototype. So anything less than 1 million, this solution is going to work. If not, the solution is not going to work. We cannot pick MySQL as database. So this one-page statement, this graph in terms of what is my threshold, a problem statement, problem description, and what is the solution for it, and what is the normal range and the threshold. That is all about this trade-off curve sheet. I'm just making it simplistic. It doesn't mean that MySQL is not going to take any request more than 1 million. I'm just trying to oversimplify this, just to make sure that how a trade-off curve sheet will look like. So it will have a problem statement. It will have some kind of a solution for it. But at the same time, for that particular solution, how long will it going to work? How long is it going to hold? After a point, it is not going to work. What is that range? This sheet is going to help guide the chief engineer, project leader, anybody who is going to lead the development team to take a decision as a consensus. So there'll be a lot of, like what the one we were talking about, there'll be a lot of trade-off curve sheets, and I pick one out of it and say, this is the decision that I've taken because I have data for it, instead of visual thinking, where I assume a particular concept is going to work, pick that as a solution. Are we clear here? So that's all about. So if there is any takeaway, right, from this session, that what I will try to remind you is, value is not just about revenue. Value is about the learnings that we do, the innovations that we do, the knowledge that is gained, how I will be able to use. So this is one single takeaway that I would like to re-emphasize is, value is not just what money that you generate, but also the innovation that you do, the knowledge ways that you do. That's more important. All right, I have wrapped up. Maybe if somebody has queries or somebody wants to share your experiences, go ahead. Anybody can share your experiences. Any queries?
Not much, but so I'm new to Lean. I keep hearing Lean, but never implemented, never practically done in part of Lean. But there's a lot of insights today because I worked in manufacturing, but I'm not in part of the production or floor shops. I'm part of the marketing or the merchandising portion. So I keep hearing from them, but now I'm thinking that, yeah, really there's lots of inputs for them even to change one small component. Great. But the documentation will be heavily, right? When I'm talking about the curve which you're talking about.
That's why they say it's on one page. So from a Lean perspective, any documentation is a waste. This is just a one-page document. So any decision that your team takes, if you are a chief engineer or you are a project leader, the first thing that you need to ask, where is the trade-off curve? It's just a one-page document. It's just going to say it's not going to work, why it is not going to work, at what ranges it's going to work. So any decision that you make, you ask for a trade-off curve. It's just a single page document.
Okay, so I have a question on this point. How faster these decisions are made? In the sense, it depends on the organizational hierarchy, or just because of seeing this paper, somebody takes an approval immediately?
I will give you an instance, like a case study of how Toyota works, right? We all have a change management process. Okay, there was one supplier in the US where he was given a design and he was made to develop that product. Okay, that supplier was wise enough to find a gap in that engineering drawing. This is a real instance that happened. Okay, he was able to wise enough to understand there is a gap in this engineering design. If you may tweak a little, what will happen is that it will be more cost efficient. So he called up this guy in Toyota where he's working in Japan. He said he's not even in an higher cadre. He said, "Look, this is what I think. Can you just come back on me?" He said, "I will call you back." He went to his chief engineer, posted this query. The chief engineer said that the supplier is right. This is nothing but a change process. Okay. The next 2 hours, this guy called up the supplier saying that next day, a new engineering document will come to you. That is how fast that change project management process is. Why does that happen? It's because the chief engineer has the control of making changes. So there is a clear-cut change management process on which are situations a chief engineer need not go to his higher authorities, or it is not going to affect anybody else. So he understands that it is not going to have any repercussions. He has the control of taking the decisions, local decisions. He gives a hands up and then he goes there. So that much faster is when you have the responsibility lying on the development team. Does that answer your question?
Yeah. It's actually pretty fast.
We all have a change process, right? In my company, there will be some kind of an call where we look at each processes go. But here, what happens is that the chief engineer knows that this is not going to have any repercussion to the entire system. If he feels that, then what he would have done is he would have taken up to his higher up authorities. Then there'll be some kind of, but there was clear-cut control with the chief engineer of what he can do, what he will not be able to do. That was very clear, written in stone. So he was able to give the engineering drawing the next day. So this is a real instance that what happened in Toyota.
Because see, since I told you I worked in manufacturing, I'm part of apparel manufacturing where we make denims, t-shirts, shirts, everything. So I am from a brand which we place orders to the manufacturing units. They come up with such an input saying that, hey, this particular wash is not correct. It is turning out a different color. But I don't have that decision power. So I need to approach the marketing team, who are the one who sold this product to the market, saying that, hey, this will be a blue product, but in production it is becoming a darker blue, which is not the same blue.
In fact, this is your example. It should not be the marketing department. It's a guy who manufactured it on the floor should decide on it. Am I right?
No, in the sense the pre-production piece, which is a lighter blue, but in production it's turning into a darker blue, which is not the same. There is some chemical issue which is turning into darker blue, but the real product just to be sold in the stores are lighter blue. So for that, to take a decision, it actually takes for us at least 2 weeks time to say, yes, okay, we are okay with darker blue, or cancel, don't make any proceeding further in the production.
So that's a waiting time for it. That's why we do it. So when you have this value stream, if you have made a sketch there of sequence of steps, come out with this value stream, what happens is that you would have seen this lead time or cycle time where you would have had that waiting time. So that's considered as freeze. Now what happens is, how do I make this 1 week to 2 days or 3 days? That will be an approach if we follow this.
Yeah, I'm thinking that we're actually wasting time to take a decision because nobody has the power to decide. It's a cycle or it's a chain reaction. Like everybody has to escalate it to the next level.
Right.
Got it.
Any other questions? I'm really sorry. I think we almost took another extra hour, I guess. I really didn't know. Almost.
No, we are just bang on. We're on time, actually.
Yeah. We should have completed it by 8 o'clock, almost 30 minutes more. Any other questions or any of your experiences, please do share. All right, I take it as no. Thanks for hearing me out. Thanks a lot. Thanks, guys.
Thank you so much. Thanks for the valuable information.
Thank you.
Thank you.